Hello, welcome. Today I'm going to be doing a bit of bicycle wheel repair. This is actually the rear of the first set of wheels that I ever built. Alex Rims Evo Super Comp rims, Shimano XT hub, Sapim race spokes and nipples. It's a tubeless setup using Gorilla Tape as the tape inside to stop the air leaking out through the spoke holes. This has been on two different bikes. I originally built it for a cyclocross bike, on one Dirty Disco. Worked really well on that. I'm about to put it onto my next build, which is going to be a Genesis Tour de Fer, and unfortunately got a bit of a problem that I'd like to fix before I do put it onto the next bike. It's got one of the most common problems probably with spokes on rear wheels. You'll notice I've taken the cassette off already. Despite me usually being an absolute stickler for having my derailleur adjusted properly, I don't know what happened, but obviously that wasn't quite working according to plan with this wheel, because the chain overshifted off the top cog, and you know what happens next. So I'll just show you the details of the damage to the spokes. One, two. It's this that particularly concerns me, where there's a real kink in the spoke with also some metal shaved off. That's a recipe for snapping in my view. That one's not too bad actually. I may well consider not bothering to replace that one, because that one is pretty good. It's quite straight, minimal amount of metal taken off. That one as well to some extent, although it's got a little gouge there. And then we get round to the ones that are much worse. Clearly I managed to stop pedalling, or maybe the chain jammed, which is more likely, before I got a full rotation of the wheel. Needless to say, a dork disc wasn't in place, although I might actually put one in place depending on how easy or difficult this is going forward. I know that's a hugely contentious issue, both from a fashion point of view and whether they actually work or not, and then wind resistance and all that, although I'm not really fit enough for that to be too much of a concern for me. So I'd like to replace these spokes. There's a lot of debate on whether you need to. You know, there's a school of thought that says just keep going until one of them snaps. You know where it's going to snap. It's going to snap either when you're on holiday or when you're really far away from home. It's going to snap at the most awkward time. I'd rather replace them while I've got the wheel off before I've built it onto a new bike. So that's what we're going to do. Going to be replacing all 8 of the outer drive side spokes, because they've all been crunched to more or less of an extent. So the first thing we need to know before doing this is how long are the spokes that we need to replace it with. I am in the fortunate position that I kept all the records of when I built these wheels, so I know exactly how long the spokes are, 292mm should you be interested. But if you're not in that position, then you're going to need to take one off and measure it. So I've already got a set of 8 Sapim race spokes of the right length. I'm going to reuse the nipples because I know the history of this wheel. I know it hasn't had a terribly hard life, so I think they'll be fine to reuse. I'm also going to take the opportunity to redo the tubeless. You probably could do this job without, but I can't remember how close the tape is to the nipples on the other side, so whether the tape's actually going to stop them turning cleanly. And also there's a whole load of old sealant inside here which I'd like to clean, so I'm going to do that. So I'll just say a little bit about my bicycle wheel building experience. I am by no means a 20 years experience expert in wheel building. Having said that, the 4 wheels that I have built have all worked really well first time. They've not needed any adjustment. They've all been strong, they've not fallen apart, etc, etc, etc. So I built this pair. I built a 20-inch wheel for an ice adventure recumbent trike, put a Sturmey Archer 3-speed hub in the centre of it, so rebuilt that, and then I rebuilt a rear wheel for my Surly Moonlander, and that made my brain hurt like nothing else, because if you know that frame and that wheel, getting the offset right, quite a bit of brain work, and went through it about 3 times to make sure I'd got it all correct before I ordered the spokes. But that wheel also worked very well. So that's me. I've learnt pretty much all that I know about wheel building from a book called Wheel Pro, which is available as an ebook, very reasonably priced, and I must say it's excellent. If you follow the steps in that book, if you're anything like me, you'll end up with a really good set of wheels. So I felt it was important just to give you a little bit of background for when we come on to the next step, which is when we're doing a job like this, so replacing 8 spokes, do we dismantle the whole wheel and start again, or do we replace them one by one? I searched this quite a lot, and as with a lot of things, the opinion seems pretty much split. People are saying if you're replacing more than a couple of spokes, you may as well rebuild the whole wheel. Others are saying if you've got a good wheel to start with, you may as well just swap them one at a time and make your life easier that way. I'm going to do the swap them one at a time option, unless it becomes apparent during the course of that I'm wasting hours of my time needlessly, in which case I'll swap over to the rebuilding the whole thing. But this wheel is still pretty good in terms of lateral and radial trueness. It's pretty close, so it hasn't been significantly compromised by the chain crunching the spokes. So I think it's worth doing it that way rather than dismantling the whole thing and starting again. I'll just show you the bits and pieces I'm going to be using for this. So there's the spokes we've already talked about. The truing stand, the Wheel Pro book that I mentioned actually has plans for building one of these yourself. You can no doubt tell by the wood and the quality of the finish that this truing stand was one that I built myself using those plans. The finish is not a reflection of the plans. Actually, the ones that the book shows, the one that the book shows is of a much higher quality, but I built this out of OSB that I had lying around in the garage. And then the gauges are some pieces of plastic, black plastic or dark blue plastic, deliberately so that you can see light through them against the lighter background below. It's adjustable, so that arm moves in and out to accommodate different widths of wheel, and then it's just clamped in with the wheels just clamped in with the quick release skewer, as you could probably see in the last bit of video. So this goes against the wheel that way, and with that one you're looking at radial trueness, so you're looking at whether the wheel is coming towards and then away from that gauge to enable you to judge radial trueness. This one is for lateral, so you're looking for the wheel wobbling from side to side as you spin it. You'll see quite a wobble on this one. That's actually more of the tyre than the wheel, and I'll show you that when I've taken the tyre off. The only problem with this, I guess, is that the way I've got it set up, it's a bit more difficult to check a wheel with a tyre in place. You could prop this up, turn that around like that, or like that. But as I said, I'm going to take the tyre off anyway because I want to redo the tubeless. Apart from that then, we've got the essential spoke key. Got some tape. This is to make little tape flags to put around the spokes, so when you're tensioning them you can see how much the spoke is twisting and how much you're actually doing up or undoing the nipple, because if you're turning the nipple but all you're doing is twisting the spoke, then you've not actually changed the spoke tension at all, so you're not going to achieve what you want to achieve. And then last thing here is a Park Tool spoke tension meter. The book talks about plucking the spokes to get an idea of tone, to make sure that the spokes are similar compared to each other, but with the relative little experience that I've got, it's very difficult to judge the tension. So I bought one of these just so you can get the tension about right, so you're not going crazy with the tension in terms of over tightening wheels, etc. So I'm just going to whip the tyre off and probably take the Gorilla Tape off as well inside, and then I'll be back with you with the bare wheel, so to speak, and we'll have a look at the radial and lateral trueness. We'll also check the dish. That's the other thing I haven't shown you actually. So the final thing we're going to use then is the dish gauge. This is a very basic one, but it does the job very well. Made out of plywood, piece of metal with a bend on the end, 3 cable ties holding it in place. This can slide up and down, and it enables you to check that the hub is in the center of the wheel, or if your frame dictates that it shouldn't be in the center of the wheel, you can measure the difference from side to side. And we'll be checking that before I start as well, just to make sure that I'm starting with something relatively good before I go swapping the spokes. So this tubeless setup worked quite well. So the tyre is actually pretty much stuck to the rim all round, but you can just squeeze it like that and peel it away. So that's nice and clean. The tyre, less so, and it was things like this, big globs of sealant that have accumulated when the wheel's been sat, when it's been off a bike, when I've not been using it, that I really wanted to clear out so we could start again. So kind of just a case of picking it out really. I'll not video that, but you get the idea, you know, little globs of glue like that. So we'll do that, get the tyre ready to go back on, move on to the wheel. Alright, now we have the bare wheel in the truing stand. I've had a good look at it. Actually the Gorilla Tape, I said earlier that the tyre seemed to have picked up the edges of it a little bit, but actually it hasn't. The Gorilla Tape looks really good, and with that in mind I'm actually not going to take it off. I've also tried turning one of the spoke nipples. One of the other concerns I had was that the tape would be sticking the top of the spoke nipple, so I wouldn't be able to turn it. But I think I actually might be misremembering. This rim has a hollow section in it, so I don't think the tape is actually touching the spoke nipple. When I turned the spoke nipple it turned absolutely fine. So I'm not going to redo the tape because it looks really good. That would be a complete waste of time. I'll show you what I mean. So I'll just give the wheel a little spin. Hopefully you agree with my assessment that the tape looks pretty good. That seal around the valve hole looks alright. Obviously I'm going to give this a bit more of a clean up before putting it back together. So the next thing I'm going to do is check the radial and lateral trueness of this wheel before I start. I'd like to know whether I'm starting with something good or something terrible. I mean, just spinning it quickly, I hope you agree that that looks pretty good, not perfect, but pretty good. So we'll look at the radial trueness first of all. Hopefully you can get an idea of what I'm seeing here or what I'm trying to look at. I'm actually looking at it through the camera because I can't look at it directly. Basically what we're looking at is the gap between the rim and the gauge getting bigger or smaller as we spin the wheel, and I've got to say that is pretty good. So that, to my mind, to my eye, that doesn't need any adjustment at all. But we can get an impression of a slight wiggle from side to side, so the lateral trueness might need a bit of adjustment. So let's have a look at that now. So I'm looking at the gap between the gauge as we spin the wheel slowly. So you see just there, you see that? There's a little bit where the wheel goes away and comes back. So that's indicating that the rim is too far that way. So either we would need to loosen a spoke that's pulling it that way, or more likely, given a rim that's this old and has never had any adjustment, there's a loose spoke on this side, so we need to tighten a spoke on this side to pull the rim that way. I might end up actually tightening a spoke that I'm subsequently going to remove, but for my own interest as much as anything, and also for the video, I'd like to start with the wheel as good as I can, so I have a good idea of what happens when I take a spoke out. Alright, so next what I'm going to do is find that bit again. Quite difficult for me to do that with the camera where it was, because the camera was exactly where I wanted my eye to be. So I reckon the centre of that bend is about there. So what I'm going to do now is twang the spokes and see if we can hear any obvious differences. In case you're not familiar, the spokes on this side should be tighter than the spokes on the non-drive side, so that's an example. So are there any loose ones on the drive side? That one sounds a little bit loose. The reason for this, you need to leave enough space to get your spoke key on there obviously, is to assess for spoke twist. If I turn this but all I do is twist the spoke, then I've not actually adjusted the wheel at all, so I've wasted my time. So this tells you how much spoke twist you've got. Now another thing that you wouldn't have to think about if you're doing this all the time, but I do, is which way is doing up and which way is undoing. So what, just engage your brain a little bit to think on that before you start going for it. So I'm going to tighten this one up a little bit. You might see the tape twist, then I'll keep going, then I'll back it off, hopefully the amount that it's twisted. There we go. Yeah, that one's a lot lower, so that's the next candidate. Now with those two adjustments, that is a heck of a lot better. I'll see if I can show you. It's quite tricky because the light reflecting on the stickers changes your perception of the gap as well. See if I can give that a little tweak. Maybe that's better. So that, I would say that's pretty good. Certainly for my purposes, that is a pretty good wheel now. I'd be quite happy to put that on my bike. Apart from the fact that it's still got the damaged spokes. So the next thing we're going to do is just check the dish, check that's not grossly out, and then we'll start taking it apart. So what I'm doing here is adjusting that metal piece on my high-tech dish gauge so that it is just touching where the frame, where the dropouts would contact with the wheel. And I'm also making sure that at the same time it is touching both sides of the rim and not rocking, which it isn't there. Then flip the wheel over and do the same on the other side. That's probably about 0.5 millimetre difference, which is good enough for me. That assumes that you're not building a wheel with an offset. If you are, then you've got some other calculations to do, like the Surly Moonlander wheel I described before. So happy with the wheel as it is, so let's start removing some spokes, shall we? Choose maybe, this one looks like quite a bad one, good old bend in it. Keeping it at the top so that when I undo the nipple it won't fall into the recess of the wheel or inside and mean that I do have to take the tape out and create a whole load of other problems. So I'm pulling down on the spoke and bending it slightly. There we go. So this is a 3-cross wheel pattern. Remember the way they cross. So over that one, under that one. So over, over, under. Quite a bend on there. I would say check the new spoke is the same length, but you won't be able to because the old one's bent. Looks about right, however. Okay. Now the wheel has got an absolutely huge wobble on it, as you'd expect, probably about 5mm or more out. So over, under. And I've forgotten to lubricate the threads before I start. So just a tiny dab of oil. I'm just using a bit that's still on the outside of the oil can there, on the spokes, not too much. On the threads I should say, not on the spokes. Now I'll be honest, that was more fiddly than I thought it was going to be. Thought you might be interested to see how bad the wheel gets when a spoke's missing, so have a look at this. That spoke's back in, but it's loose. So I've got my piece of tape on it now, and I'm just going to keep tightening that up. You see already that's started to get better. Getting better again. So in terms of the tension, that's the replaced one, and those are the ones either side of it. So we've still got a little bit of tensioning to do. Right, so now the wheel is back to completely true in terms of lateral trueness. And that spoke, it's not identical, but they never will be. It sounds pretty similar in terms of tone to the ones next to it. So that is our first spoke replaced. With the old spoke out and in my hand, I don't know if the camera will focus on it. I can see, or I can say, I'm quite glad I replaced that, because you can see it's got a gouge out of it if you look at it from the side, and it's got quite a clear kink in it there. Having shown you that one, I don't think there's any point in showing you the remaining 7, because they're all going to be exactly the same. So I'll crack on and do those, and then I hope I will be back with you shortly to show you a finished wheel. Okay, nearly done. 7 spokes there taken out. They actually end up looking more bent when they're not under stress than when they're under stress in the wheel, so I've decided to do the full set of 8. I'm also aware that I've probably become a bit more proficient at doing this in the course of doing the last 7, so I thought I'd just show you the last one, which is this one. So you get to a point where when you're unscrewing the nipple it goes inside the wheel, so I've kind of just been tensioning the spoke with my thumb and fingers like that. And there comes a point where it's clear it's loose. Keep that at the top so the nipple doesn't fall out. I actually found it was better to just start turning the nipple with the spoke key from the outset. Eventually it tightens up and you can let go of the spoke without it poking back through the rim tape. Still got a bit of a bend in it, so as in the wheel's lateral trueness isn't that good, so tighten up a bit more. Okay. So we've changed all the spokes. The wheel is true both radially and laterally again, as it was when we started this whole process. Next step is to stress the spokes. A couple of ways of doing this, but the way advised in the book that I follow is to choose pairs of parallel spokes like that. Make sure you're not looking directly down into the spoke holes just in case they twang. Put some gloves on in case they twang and give them a squeeze. Try and remember where you started, unlike what I've just done, so I'm probably going to be going around more than I need to. But hey, if some of them get it twice, no biggie. Right, there we go. Back in the stand. And then we see how much it's messed up our wheel alignment. So the radial trueness first. You might be able to tell there's an ever so slight bump. That gap between the gauge and the wheel is less than 1 millimetre. The book talks about an accuracy of 0.5mm for radial trueness and 0.2 for lateral. I might try and adjust that out a little bit, but it's one of those things where you can spend too long doing this, and it's very tempting to aim for perfection when it's very difficult to achieve. The more you fiddle with it, the harder it gets, so to speak. So I might try and get that a bit better, because it was a bit better than that at the start. Now looking at the lateral trueness. So there's a little spot about there where the wheel just moves away. This is also very difficult because we've got stickers on the side of the wheel, which I think I said earlier make a difference both to your perception of the gap, and also they make an actual difference to the gap because they stick out. You can probably tell there's a spoke there that is slightly lower pitch than the other, so just give that a little tweak. Probably a bit too much. Still a bit too much. I'm just going to check that. I can't actually check it as well as I usually can because the camera's in the way. So I'm just going to check that again, and then we'll see where we go from there. Okay, so the final things to do are to equalise the spoke tension, then check the spoke tension, and then also check the dish. I'm not going to show you checking the dish again, I've actually already done it. It's exactly the same as it was at the start. And again, the book talks about being within 1mm of completely equal either side. It's well within that, so that's absolutely fine. So spoke tension, I think the point of this is that if you've got one spoke that's far too tight and then one spoke that's far too loose next to it, your wheel isn't as strong as if the spoke tensions were all similar all the way around. We've already said on this wheel we're not going to get the spoke tensions the same on the drive side and the brake side. I'll show you what I mean by that. So this is the drive side. We'll try and start the valve so I don't lose track of where I went. So that one seemed a bit tight. Those ones either side, a little bit looser. But not bad, they're all pretty close. Then the other side. They're all pretty close as well. So looking at around about 125 kilos of tension, the Park Tool spoke tension meter has got a table for different spoke thicknesses. These are 1.8 millimeters diameter in the centre and then 2 at the ends, double butted spokes. For that we're looking at a number of between 22 and 23 on this gauge. So that's 23. I don't usually check each one. 22. 23.5. I wonder if that was the tight one. No, it wasn't. Just shows the limits of the accuracy of this. Anyway, in summary, the spoke tension's about right. Measuring it on the tighter of the two sides, so the drive side. So I'll just see if I can sort out that slight difference in tension. There was one that was particularly high. Let's just find it again. That's that one. So let's see if we can just back this one off a small amount. And do each of these up. About half the amount that we backed off that one. Okay, so that's better. There's still a bit more work to do on it, and I'm going to carry on and do that now. I'm not going to just video the whole thing, and you get the idea. If you find a tight spoke, you slacken it off slightly and you tighten up its neighbours, each half the amount of the one you slackened off. Keep going until they're roughly the same. You're never going to get them absolutely right, that's my view anyway, and keep going until you get a wheel that you're happy with. I'm happy with this one now. All of those adjustments I've made didn't make any difference to the lateral trueness. I'll check whether they made any difference to the radial trueness, but I don't think they have. No, exactly the same. So this wheel now is pretty much finished, ready to go. So we'll put the tyre back on, put some sealant in, and then blow the tyre up. So in case it wasn't obvious what I was doing there, taking the valve core out, using a blowgun rather than a tyre inflator to get maximum airflow in, to seat the bead. I should really be using washing up liquid or something like that, but I rather naively thought that because I've set these up once already, the tyre would go back into shape a bit more quickly. Okay, so the air pressure now has hopefully forced the bead back a bit more into shape, not completely, but hopefully enough that when I put the valve in now, we'll actually get a seal and we'll be able to inflate it. So next in my list of schemes for getting a tubeless setup to inflate is to use the air blow gun with a piece of tube directly onto the valve stem with no valve in it. So that was working much better. It was seating the bead, but then as soon as you let the air off while the air's leaking out, because there's no sealant there, so I moved onto the floor, because what we need to do now is seat the bead. There we go. And everywhere where you can hear air leaking out, hold that bit at the bottom, let some sealant go into it, and then in time it should improve. We may need to put a bit more sealant in this because I lost a bit when the bead popped. The best way to do this is to take the bike out for a ride. I mentioned earlier in the video this is going on a bike that I haven't built yet, so I can't really do that. So the bead's properly seated now, I hope. So blow that up to about 40 psi for now, and just give the wheel a bit of that both ways round. Get the sealant. You can see the bubbling there. We've still got a little bit of leakage there, which will need some more sealant. Can't hear that there's that much sloshing about actually, so that might need a little bit more in it because it's still leaking ever so slightly, but essentially we're done. Case of topping the sealant up, topping the air up, riding it. Best way is riding the bike because the spinning action forces the sealant into all the little places where air is leaking out. Okay, we're done. We've changed all those damaged spokes. The wheel looks much better. I've been much more happy riding it now. If you've had the same issue with your wheel and you want to have a crack at fixing it yourself, I hope this has helped. If you like this type of thing, please consider subscribing so you get to find out about more content like this that I publish. But for now, thanks for watching. See you next time. Bye.